Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing linear equations. This is standard A.2B in the great state of Texas, and we are using item number 1 of the 2018 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a restaurant with jars of tomato sauce that are stored in boxes. We don't know much about these boxes except that each box contains 8 jars. All right, so that's really all we know about these boxes. Let me just draw a picture here. All right, so here's my box. I'll just cut it into eighths. So there's my box of tomato sauce. I've got 8 jars in there, and a cook uses two jars from one of the boxes. All right, so I'm going to just maybe draw some X's here. Okay, so if there were only one box, there'd be six jars left, but we don't know how many boxes there are. So which function shows the relationship between y, the total number of jars of tomato sauce, and x, the number of boxes in the pantry? So let's see if we can set this into let's see if we can get into this. Y equals mx plus b. Let's just use our form that we've been using since the 7th grade, slope-intercept form, right? So the one thing we need to figure out is our slope, right? So what is our constant rate? And the only thing we really have here is, look at this, each. Okay, so each lets us know that we're going to have equal groups, and so that's a good clue that we're going to be dealing with this as a coefficient, right? So a coefficient is the term that we multiply by one of our variables, right? So it's 3x, 4x, 10x, 0.25x. That's the coefficient, is that first number. And right now I've got x number of boxes. So I don't know how many boxes we have. We could have 1 box. We could have 2 boxes. We could have 18 boxes. So let me just draw 3 boxes here. All right, so I'm going to draw 3 boxes. We don't know how many boxes we have, but what we do know is that we also have a constant. Okay, so our constant is going to be the cook uses 2 jars from one of the boxes. This is actually, I don't really need that number. This is one of those cases of there being extra information. We don't really need that number 1. The cook is just using 2 jars, and so when we're going to use 2 jars, we're going to view that as a taking away, like we are removing 2 jars. And so right here, this is our slope, this m, right? So this b right here is going to be our y-intercept if we were to graph this. But this is also, we can call this a constant. So it's not necessarily affected by one of the variables. So our slope here is the coefficient, right? So we already talked about that. But we also know that we're taking away 2 because it says the cook uses 2 jars. Not 2 jars from each box, that would be different. 2 jars from each box would be, it would then depend on how many boxes we have. So what do we know? We know that we've got 8 jars in each box, and x is the number of boxes. So then I'm just going to multiply the number of boxes by 8. So in this picture, I've got 24 jars because I drew 3 boxes. But if I were to draw another box, well then guess what? Now my number of jars has gone up to 32 because it's 8 per box. And I'm going to use, or I'm going to take away 2. So no matter what happens, I'm going to take away 2. So let's use this example. So let's say I've got 8, 16, 24, and then I've got an extra 6, right? Because I'm not using those 2, so that'd be 4. So what happens if I do 30 equals 8 times 4 minus 2? Does that work? And yes, if I plug this 4 boxes in, that means there's only going to be 30 left over. So that fits. So our answer here is going to be C.